Hello, hi guys, good morning. Hello, hi guys, good morning. I hope that I am audible and visible. If yes, can you please write down below whatsoever is coming up on the screen? Has the video started or not? Just write down. And for sure, like I started a bit early because I just want to finish a bit early because I've not slept since last 2 days. So I want to kind of sleep. So yeah. Going on, can you just write down the folks who have still joined in? We'll just have first and second question are exactly same. Code is also exactly same. It's just that okay, it's just a bit of optimization. We'll see question number 3 and 4. But before that, can the folks? Okay, we have Chiru. Hi bhaiya. Just folks coming in. Can you just please write down how many questions you did, how much time you took, and also like is everything okay in the video and stuff? And also like liking and stuff is just normal. So can you please write that down? Meanwhile, I'll just quickly read the first question and we'll get that going as well. Check if the string can be made equal with operation 1. Now it just says okay, I have a string s1 and s2, both are of length 4. Okay, the length is defined, but let's even say the length is n, not even 4. Then it just consists of lowercase English letters. Now the operation which I can apply on any of the two strings any number of times. What's operation like? I can choose two indexes I and j minus I, which means okay, j is here, I is here, j minus I should be equal to 2. If that is the case, then I can swap the two characters at those indexes in the string. Now it just say okay, I can apply the operation on any of the two strings to make them equal. So it makes sense indirectly also that you will just apply operation on one string and try to make that equal to the string number 2 ultimately, right? So it just say okay, j minus I equal to 2. What it means ultimately is if I have a string s with the indexing as let's say the character this 0 1 2 3 4 5 and so on and so forth. So for sure j minus I equal to j minus I equal to j minus I equal to 2 and so on and so forth. So although the length is 4, but I'm just representing what j minus I actually means. Sorry, j minus I 2 actually means, right? Here also it's a 2, here also it's a 2 and so on and so forth. So just say okay, odd indexes difference are the odd indexes ones are having a difference of 2 and even indexes ones are also having a difference of 2. So again I just want to make this a b c d equal to c d a b. The operation I can apply is shuffle, or basically have it shuffled this thing and have this shuffled this thing. So ultimately you just know okay, anything whatsoever is here, I know I can shuffle this up. So there are many ways to solve it. One of the ways, okay, Aryan, get the strings, let's say a and c, get the strings c and a, just sort it down or just compare if the frequencies are same. Or just compare after making the entire string a and c, just to sort it down, make the string a and c just okay, now the strings are equal, so still also it's the same. All the most easiest ways, as you know that ultimately your these two places, which means if I have these 4 places, so the first and the third place will have something, but here also it should have something. So even after shuffling or doing anything whatsoever, the characters will still remain a and c at these places, which means it can have a a or a c, it can have a a or a c, but the count and stuff will actually remain same because I'm just shuffling at these places itself, and that's what I can do. So I just ultimately need to check okay, the count of characters at this location and at this location, if it is same or not. If it is same, for sure I'm good to go. So a and c, count of a is 1, count of c is 1, count of c is 1, count of a is 1. So for sure I can anyhow, because ultimately I have a chance to shuffle any way whatsoever, I can just shuffle any way whatsoever and just can get this string. So just get okay, and you can solve it in many ways because the length is 4. So you can just take these two characters and just compare character by character, also just make the characters as a string and then compare also, and also you can just do by a frequency. Okay, the elements at the odd indexes, what's the frequency like, and it should be same as the one for the string 2. It's for the string 1, both should be same, and for the same goes for the string 1 even indexes, it should be same frequency as for the indexes and even indexes for the string 2 as well. If they are, then for sure you are good to go, and you can say S1 and S2 both are equal. While you can see that for the, or maybe like you can say, okay, you can convert S1 to S2. Now for this example, you will see that, okay, I have A, B, C and D, D, A, C and B. You know that, okay, you can shuffle that indexes at even indexes, but here you will see you have a D and C. Here it's a but A is missing at these even indexes, so for sure that can never ever get a in these even locations, because I can only shuffle A's. So basically the even locations will have only the even elements, which means, sorry, the even location will have the elements at the even location itself, and which is not the case for it. So I can have A and C only, while I can never get a D at even location. So false, like not possible at all. So the most easiest way is, and usually it helps us, okay, get the frequencies of the elements at the even location, get the frequency at the element of the odd location, and it should be same for the string 1 and string 2 exactly, and that's when you can convert string 1 to string 2 entirely. Cool. I hope that you guys got it, but before that, if the folks who have joined in or who have still not joined in, although the live stream had to start at 11:30, but still I started it a bit early because I want to finish it a bit early as I had to do some work. But if the folks have joined in, can we please smash that like baby to 10 likes? यार, you guys are regular हो यार, फिर भी ऐसा कर रहे हो. Just 2 more, that would be super great. We will quickly see the code again. I'm saying if you have worked on question number 2, it's exactly same. It's just that the constraints of length 4 is not there. It's just an n. That's it. Or just it is indirectly mentioned about this condition also. So still, the code you will see that it will be exactly same, and so it's just, okay, getting the odd location indexes, sorry, getting the odd location frequency, which means the odd indexes frequencies, getting the even indexes frequencies, and that should be actually equal for S1 and S2. So we just went on to the entire string. You can go S1 S2 both, you can go, because both have the same size. Now if the indexes is actually odd, so you will just go and say, okay, indexes is odd, so for that odd and the index is odd, right? So you need to update the odd index array. So you'll update the frequency and you will just add the frequency, but you ultimately also want to compare and have it for the string 2 as well. So you can just do one thing, maybe just increase it for S1, decrease it for S2, ultimately just check in the end that it should be 0. Or you can do one thing also, just increase for S1, increase for S2, and ultimately check in the end that it should be same. Any way you can go whatsoever. So increase for S1, decrease for S2, and ultimately we'll check that it should be a 0. If it is not a 0 anyway, okay, it's not possible, which means I will return a false. But if it is 0 all the way, which means for the entire odd array size of size 26, I can simply return a true. So, and the same I will do for even indexes, okay. For S1, increase it, for S2, decrease it. Or again, I'm saying there are multiple ways to implement it. You can increase S1, you can increase S2, and then compare in the end also. Okay, both should have the equal size and every element, which means at every index value should be equal. Just comparing, okay, at the odd indexes frequency should be same, at the even indexes frequency should be same. Cool, and that's how you can just simply get this done. Ultimately just checking both odd and even at every location should be 0, because you are just increasing and decreasing, right? So it should actually be a 0 and simply return a true. Cool. We quickly go on to question number 2, but before that, let's see. Ayush 3/4, Priyansh 2/4. Hi bro, hi Chakradhar. Learn everything 3/4. That's great. If I have not solved question number, but yeah, can we please smash that like baby to 15 likes? That would be super great. But for the folks who have not solved question number 4, that's primarily a just basic PNC, or you can say as just simple implementation of NCR if you had ever solved a question of just a simple basic maths. So that would have been easy. But apart from that, if you just keep on watching these videos, then for sure you'll just get good at it. But please practice it by yourself also. Anonymous, like, why is not my phone working? But yeah, 4 dal 2/4, Ikansh 3/4 today, Anonymous 3/4. देना चाहिए था आज कॉन्टेस्ट सॉल्विंग में 30 मिनट में 3 हो गए. बाय द वे, डू यू हैव एनी प्लान्स ऑफ Restarting CF contest problem discussions. I will. But for that, I need a bit time to actually sort those things out, which are remaining. Second वाला में गलत directions में सोचने लग गया था. So like usually, like as the name also says, it was a 1, and as soon as I read a 1, I knew that okay, a 2 will be coming in, and that would be for sure. That's nothing but if you have seen code forces just saying okay, B2, sorry, B and like B2, and kind of just saying okay, it's an easy implementation, it's a hard implementation, so it's the same one for it. Although both were easy, it just says that okay, now the string is of length n, and also now I can just go on and I can just say okay, j minus I is even, so that j minus I is even, which means j minus I is a multiple of 2, is a multiple of 2, 2, 4, 6, and so on and so forth. Again, if that is the case, so for sure what you can do is you will know okay, 0, 1, 2, 3, 4, 5, 6, 7. So you can compare 0, 2, you can compare 2, 4. That's okay, 2. Now you can also compare 0, 4 also, 0, 6 also, right? 0, 6 also, and 4, 6 also, 4, 2, 6 also. So all the multiples, or basically all the even indexes, I can shuffle them anyhow whatsoever. So okay, that is one case. And again for this 1, 3 and 1, 3, I'll change the color, and that will be 1, 3, 1, 5, 1, 7, 5, 1, and again same stuff. Okay, with this condition I can easily say that I can shuffle all the odd indexes also. So that's how you can easily say okay, the same code as we saw earlier, that okay, shuffle the even indexes, shuffle the odd indexes, and you would be good to go. Again, exactly same code, having the odd indexes and even index frequencies, getting and comparing them, which means increasing for S1, decreasing for S2. Or you can also, again I'm saying also you can have okay, odd 1 or 2, which means increase for S1 also, odd 2 increase for S2 also, and then compare in the end, which means for all the frequencies it should be same. Or you can just have one only odd and increase and decrease, anyway whatsoever it will work. Again for even, you can just increase it, even decrease it, and simply get that okay, the frequencies at the even location should be same, the frequencies at the odd location should be same for both S1 and S2. If that is the case, simply return true. If not, then simply return a false. Cool. We're quickly gonna jump on to question number 3. Before that, we will have some chat discussions. Before that, can we please smash that like baby to 15 likes? That would be super good. I know the contest had been pretty easy today, but still, if the folks are watching in, if you are the regular ones, then you can just please smash it. Now only I can see that the many are regular, like Akshat, Akash, Fordal, Anonymous, Ekansh, Vitamin Protein, like he has been since so long. Ekansh also, Chakradhar also. So yeah, like you guys are regular, so for sure have that done already, but not, if not, then please like it. Now let's have it 15. We'll quickly go into question number 3. If you have any questions, any doubt, just write down below. That would be super great. Maximum sum of at most unique sub array. Now again, you are having an integer array nums and 2 positive integer m and a k. Cool. Return the maximum sum of all at most unique sub array of length k. So basically the prime thing is I have to get a sub array of length k. That's one thing. And what is at most unique? Basically just says that okay, it should have at least m pairwise distinct values, which means when it says pairwise distinct values, it actually means, and that's a very normal statement, saying pairwise distinct values, it just says it means unique values, right? Which means okay, if I have some values, every value is pairwise distinct to every other value, which means every value in this array is a unique value. So I should have unique values greater than equal to m. That is one condition of a sub array of size k, exactly k, and that is what I need, and I want to find the maximum sum. So ultimately I know okay, I have a kind of an array, I want to choose a sub array, I want to go and have and try every sub array of length k. Now I just need to also make sure okay, that sub array of length k should have number of distinct elements, let's say d, it should be more than equal to my m. If that is the case, then I can get its sum and I can just keep on getting my maximum sum as my answer. right? Maximum sum as my answer. And that's simply. Now if you just break this problem down, then if I just ask you, hey bro, can you just give me all these sub arrays of length k and give me the sum of it? Now you know the constraints are pretty low, then you can't go on every sub array again and again. So kind of, if you want this, okay, now you know it is the first sub array of length k. What is the next sub array of length k? It is this one. Again, you know that, okay, you had a window of length k, you will slide that window down to the next window to get the new window. Again, you will slide the window down to the next window. Again, it's a sliding window problem that you know from very basic. Now the twist is, if I just have asked you, hey bro, can you just find the sum? Now again, forget this part of m. If you have a window of size k, now I know, okay, you want to go on to every window of size k, so you can just slide the window down to the next window. Now as you want the sum of that window of size k, so you can just go and find the sum of this window. As you have the sum of this window, which is sum is equals to 2 plus 6 plus 7 plus 3. It is sum. Now as you will go on and slide the window to the next window, what happens is you will enter the new element and you will exit the previous, like last element of that window. Now as you enter the new element, you know that you have to exit the previous element, which you will exit as 2. So now with this O of 1 operation, you can just get the sum of every window, right? And how you do it? You know that the length is k. So if I have a 0, 1, 2, 3, 4, so I know that, okay, my window ended at 3. My I is here. Now my I is here. So I will include this particular I, and I have to exclude I minus k. Right, I minus k, I have to exclude so as to get a new window. So I'll just know, okay, I'll add in my sum, I'll add my nums of I, and I can add my nums of I, I can subtract my nums of I minus k. And that's how you can just get the sum as you slide the window down. Okay, now you have got the sliding window approach. Now you have okay, it's just a quite modification in that equation. It's just that, okay, you will get the sum and just want to maximize that sum. So that's a standard operation which you can just apply, keep on going on every index. Now, okay, I'll go on to next index I. For this, okay, it is the window, so I minus k, okay, it is actually a 4, it's a 5, I minus k will land to a 1, so it will get excluded now, so new window will be this. So I'll get the new sum, and I can just get the maximum sum by just, okay, saying answer equal to maximum of answer comma this current sum, and current sum I'm updating by this. The only switch or the only addition or the only difference in this is that you will have someone note, I don't know if it is for saying loudly, I am speaking loudly or not, but yeah, cool. Let's continue. Like, can we please smash that like baby to 20 likes? Just one more, that would be super great. Cool. Now just the only thing is, okay, the number of distinct elements in this entire stuff should be more than equal to m. Now, how to know the number of distinct elements? Simply, you can keep anything, a set, a map, but map is much more convenient because map size will give me the number of distinct elements in the map. And for sure, I can also keep, okay, if I have, okay, map saying, okay, map of 2 is actually a 1. Now, if it is a 1, which means number of unique elements increased. If I just encountered a 2, so map of 2, which means the frequency of 2 increased to 1. Okay, I got a new 2. So for sure, 2 came in first time, so unique elements increased. See, there are again multiple ways to solve it. One of the ways is you just use a map. You just increase, okay, let's say I encountered a 2. I increase the frequency of 2. I encountered a 6. I'll increase the frequency of 6. Now, if I just ask you number of unique elements, you can just give me the size of the map. Cool. Then so let's say I asked you, hey, again I encountered a 2. Okay, cool. The frequency of 2 will increase. Again, I ask you, what is the number of unique elements? You can again give me the size of the map. Okay, give me as 2. But let's say I ask you, now the 6 is gone. So, okay, it has gone to 0. But as I just do a minus, which means my map of 6, its frequency now reduced to 0. So now it is my authority to actually remove it from the map. If we do a minus, still, if I just ask you, it will give me the map size as 2. So if the frequencies get reduced to 0, so you can just say, okay, if it is at 0, then remove it from the map. So you have to explicitly remove it from the map so that it is exactly gone from the map. Now if I ask you, Now the map size is actually a 1 itself, which will say a number of unique elements in my map. So that's one way. Or the other ways, you can just maintain the frequency or the number of unique counts as you will encounter. Okay, I got a 6, so number of unique elements are actually a 2 right now. Okay, I just increased, let's say a 2 came in again, so its frequency got increased to 3. So as increased, the frequency got increased to 3, and not it is not 1 now. If it had been 1, which means it had become 0 to 1. Oh, a unique element entered. Now it is 3, which means a unique element never entered. So the unique elements still remain at 2. But let's say if I ask you, a 6 is gone now. If I say if a 6 is gone now, okay, it will just reduce to 0. Oh, it reduced to 0. Oh, which means an element is gone completely now. Okay, unique elements are decreased. It's 1. So you don't have to actually remove it from the map itself. It's still gone because you are maintaining the uniqueness in a different variable, let's say unique. But if you are using map size, so please make sure as soon as the frequency, which means the value, it reduces to 0, please remove it from the map also. So that's one thing which you need to make sure while actually using a map, to know, oh, okay, I'm using the frequency out, which means with the map size, I'm using okay, how many number of unique elements are there? And that's the only thing which you have to do extra in that code, just okay, while iterating in my entire. And again, it's a sliding window approach. New element came in, I came in, I minus k will go in. Again, the frequency, which means just MP of nums of I will actually add. Now after adding, if it is a 1 frequency, which means I encountered a new element, okay, so increase the unique variable by 1. Let's say if it had been 2 or any other element than 1, not a 0, I'm saying. So which means, okay, after encountering it, it was not unique. So please maintain whatsoever frequency you had. Please keep that itself. But okay, if I remove I minus k, which means I will do a MP of nums of I minus k minus minus. Now after doing a minus, if the frequency, which means if the map of this value becomes a 0, oh, this element is gone. So please remove or please if you have to decrease the uniqueness, whatsoever uniqueness you have, let's say the value was u, so please decrease it by 1 because one of the elements is gone completely now. So please, that is done. So that's how you can just get the uniqueness or the number of unique elements in the entire subarray, and that's all. Okay, again the same for the sum also, you will have sliding window. For the uniqueness also, you will have a sliding window, and you will just maintain a sliding window to actually reach the final end and get the answer. That's completely what you have done, and that's a problem. See, this uniqueness part, which means getting the number of distinct elements or getting the number of unique elements in the subarray and then going on in the sliding window kind of approach, we have solved it previously also. This part also, to get the sum of these subarray, we have again solved it previously also. Both we have solved. It's just that it's just a mixture of both of them. That's it. Cool. Let's quickly have a look at the code. Again, there are multiple ways to implement it. I showed you both the ways to implement it. Again, here we will have a unique variable. That's much more short and concise code. Still, other code will be same for that also. But yeah, it was looking more clean, so I just picked it up. Now, unordered map to actually keep the elements in the entire sliding window. Now we will have okay, that's a forward, that's a backward. Now as I encounter an element, as I'm moving forward, like my one pointer is moving forward, you know that I have a pointer moving forward and one pointer will be back, right? To actually remove the back elements as well. So as I am moving forward, so it will just keep on adding in my sum. Now I will also increase the frequency as I showed you as I encounter an element, which means forward. Okay, I am encountering an element, I will keep on adding in my unordered map. Now for sure, if it is a 1, which means I have encountered a new element or a unique element, so okay, increase the unique element, which means the number of unique elements by 1. Again, if my forward have reached a benchmark of k, now I can start evaluating my subarray. What it means is that the indexing was 0, 1, 2, 3 and 4. Now if I have reached my forward as more than equal to k, which means okay, now I have got the array size of 4 for sure. So now you can start evaluating your subarray, right? So if it has reached, so you can just start evaluating your subarray. Now as you know that okay, when you evaluate, which means when you were actually at k, so you will be removing this back and you will remove and you will add this front element. So okay, if my forward has more than equal to k, which means I will just remove the back. Also I will decrease the frequency of back, because for sure the back is going right now. Now if it becomes a 0, okay, my uniqueness is also decreasing, and I'll increase my back pointer to actually now say now this is a new window. Again, when this is the new window, this is the operation which I can perform only when I have actually gotten one window itself, right? Again, anytime if the uniqueness is more than equal to m, I can actually start counting my answer. So if the uniqueness, only when the uniqueness is more than m, I can start counting my answer by saying answer equal to maximum of answer comma sum, and that's how you can simply get this solved as the answer. Cool. That is for the question number 3. Again, that's just an O of n operation, and simply get this done. Again, I'm saying I showed you both the two approaches to actually solve this. Approach is same, it's just that the code implementation might be different, how you use a map and how you find the uniqueness of this number or the frequency or the kind of number of unique elements in the entire subarray. There are multiple ways to solve it. Cool. Let's quickly go into question number 4, but before that we'll quickly have a chat read. If you have any doubts whatsoever, you can just quickly write that down. But before that, can you please smash that like baby to 30 likes, just 3 more, that'd be super great. Good message visiting our college for hiring interns. Could you please help me? Yeah, that's see, if they're hiring for interns, still that would be same kind of aptitude round, coding round, and English round also. They also have that English round also. But yeah, just have a visit at Google, like as in like on Google. Just look at what Coleman's ask. Aptitude round puzzles, also get them ready, because puzzles also a good topic for them to ask. They ask a lot of puzzles also because it's just fun. And also, if you are please bit focus on permutation combination questions also, because I had been asked the permutation combination question in my internship at Goldman. I am MS Darshan. Okay, MS Darshan. Change the name, Smokey. Cool. First time I was able to solve 3 questions out of 4 problems. That's great. Supratim, bhaiya, how many hours code every day in Leetcode code forces? As much as you can. If you are in third year or more, just get things done, get things sorted, and try to code as much as you can. Or maybe if not code, at least think for a problem. Okay, how it can be solved, how it can solve. If you are stuck, then go and solve, then go and watch this solution. But if you are progressively thinking, or you are incrementally thinking, or you're your thinking is going forward, then for sure keep on thinking the entire day itself. That's good. Because see, when I say thinking, I never mean to pull to get down pen and paper and then start writing stuff. It just means that you are while eating, you are thinking, okay, it was a subsequence. Now I want a subsequence and it should have maximum frequency. So what I will do is I will choose the element of the maximum frequency and use. So that's how, in your mind itself, by eating itself, you are just thinking of the problems itself. That's how coding actually works. Cool. I'll quickly have a chat read. With that, we'll start off the question number 4. Before that, can you please smash that? Yeah, you guys are regular. Yeah, regular. Okay, come se come. I was expecting at least 50 before starting the stream. But yeah, you guys are 30, just one more. Cool. 2x4, Akshat, I am third. In third, उसमें pairwise distinct लिखा. Instead of this, they had right distinct elements. Pairwise से सब confused हो गए थे. See, Akshat, Jen, I don't know that why people got confused by pairwise distinct, but it is a very, 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 very generic term in programming to define distinct elements or the unique elements while saying that pairwise distinct. It is the best term to define that in an array you need to choose unique elements, or the elements needs to be unique in that particular subarray, and that's the very standard common term. I don't know how the F people get confused in this, because if you had been solving the problems since last 6 months at least, or even less than that, still that is a very common term, and that's the best term to actually define that. It's because else every other term, let's skip that, then every other term other than this will actually have multiple other meanings. So that people should be used with it. But yeah, I just have a recommendation that at least it should, like, all these folks, like Leetcode folks, must have defined what this term means, because people might not be familiar with it. So, but yeah, this is the best term to define unique elements. But yeah, Leetcode folks should have write it down that okay what it actually means. True chat dekh lo. Hey Aryan, but I haven't seen the paper is saying before, so it wasn't a problem. Yeah, that's true. Yeah, but it confusing newcomers, so this is not pretty right things. Yeah, that's true also. People confused in case. Yeah, I wasted time on this one past. Yeah, pro, you have pretty high rating. Ooh, okay. Goldman Sachs goal. Cool. Thank you for your first time result. That's great. Yeah, how many hours you code every day in lead coding courses? See, I don't even get time to actually give the proper like time to actually problems itself. My mostly coding is done okay while contest, and not even while contest. I came in around 9:45 ish, or like more. I came in around 9:50ish at home. Then I looked at the problems from the first glance itself. First, second, third problem was very easy. Third problem was a bit tricky, but that also was very easy, solved in around 10 minutes or so. So the contest right here was actually a pretty easy one, not in comparison to the last ones, but still, like I don't get much time to actually devote onto problems at this stage, and that's a harsh reality. After actually start working, you don't get time for actually coding and stuff. So if you're in college, please, I have been in college, I know that you will get a lot of time, so please devote that time and please get things done. And like, you can do everything in college, because in college you have the entire day. Studies, colleges, like classes, just up till 5 p.m, and that also you can just bunk, proxies, or like while in class itself you can just have coding done, which means while in the lecture, while in the class, you are in the class but you are thinking of the problems and you can solve the problem itself in the class, right? So that's a big luxury. But in the office, you have to work, you have to think of the work itself, so that's not possible, because you have to give updates every day, right? So yeah. Question 4, DP wala approach batao. It's more intuitive. It could not be I could not able to finalize DP states. DP is not intuitive for question number 4 at all, like at all. I'll show you why. I am pass out and I really wanna improve my coding. Yeah, that's good. No, see, it's just that how much time you give. Like, you can still give the time. It's just that okay, how much time you can just pull off from other works and then give it to it. I solved 4th by DP. Please tell math solution about it. See, even if you solve 4th by DP, I don't recommend it, because it's a straightforward kind of a math question. But still, like, see, DP is nothing but just saying that okay, like, we will have a look, but I won't recommend that. It's firstly, it's gonna be a long code if you write it with DP, and that too not that great. I didn't do CP in college. Now I want to improve in CP after my job. I want to do good problem solver. See, that's great. Supratim, just be much regular in coding and that would be good. Close your window, bro. That I can do, but yeah, फिर मैं भूल जाता हूँ to actually open it off and गर्मी लगती है, which means like I just forget to open them back, and then like it just heats up a lot. Cool, bro. Love you. I'll die by doing this. Leetcode solutions. Goodbye, words. No worries, bro. Bamsi, like, let's have the spirit. Cool. Let's quickly go on to question number 4. But before that, can we please smash that like baby to 40 likes? That would be super great. Count k subsequences of a string with a maximum beauty. Now, just say that okay, you are having a string s and an integer k. Cool. A k subsequence is a subsequence of length k. Again, you know a subsequence. If you don't know, a subsequence basically is okay, if I have a string, so I can just choose in the characters at any location. It's just that the order is important, which means A and D will be the actual string or the actual subsequence rather than D and A, but I can just hop at any place whatsoever. But the condition is that okay, the subsequence should be of size k and also that all its characters should be unique, which means I should, in a subsequence which I am making right now, I should have k unique characters. Cool. Every characters occur once, which means okay, a k subsequence means a subsequence of size k with all k distinct characters. Cool. Now comes the next part. Let fc denotes the number of times a c character comes in s. So fc just indicates in the s, in the entire string s, what is the frequency of that character, which means for this the string is a b b d d. Frequency of a is 1, frequency of b is 3, frequency of d is 2. So these three are the frequencies. Okay, look, that's fixed. In the beginning itself, you can just pre-compute this part and you will be good to go. Cool. The beauty of a k subsequence is a sum of fc's. Okay, if I now you know what's a k subsequence. K subsequence is a subsequence of size k where all the characters are distinct, right? And that should be of size k. Remember that part. So if I have a string, I can make a subsequence, but for sure I'm concerned about the sum. Now I am also concerned about that this sum. Okay, where is that gone? The beauty of subsequence, size k. Example, it is given that how we get the sum. Okay, if I have a and a b as a subsequence, I choose a f value is 1, b f value is 3, so the f value is 4. Let's say I choose a and a d, so a f value is 1, b a d f value is this, so I'll get a 3. Now if I choose a b and a d, so b f value is 3, d f value is 2, I'll get a 5. So that's how you can simply get this solved. Again, I have to return an integer denoting the number of k subsequences whose beauty is maximum among all the k subsequences. Now again, how you found the beauty? You found the beauty by summing up their f values, and their f values are just, you can just pre-compute that earlier also. Now you want this f value, which means the beauty, as maximum, and you need to know all such number of subsequences having this beauty as maximum. So you're only concerned about this beauty as maximum, and then when you're concerned about the beauty as maximum, then you will just find out, okay, what all subsequences are there. Again, k subsequences, k as in the length should be k, and also all the elements should be unique. Now coming on back, firstly, a very standard stuff. If you don't even have k unique elements, that's very obvious, right? If you don't even have k unique elements, then for sure you will never be able to get a k subsequence. So you can simply return a 0. That's a very obvious, because if you don't even have, let's say if I say, okay, I have only a, I ask you k equal to 2, give me a subsequence. So you will never be able to produce. You will only get a, and then what's next? What's different character? Nothing. So you maximum the subsequence you got as a. So that's not the answer, right? So for sure, one thing is you can choose the back. Now we are just looking at the example itself, how we can solve it. But as the word itself says that what you have to make, then you will think, okay, what will never be possible to make. So just one thought, okay, if the characters are not even that k, which means number of unique characters, or the number of characters, also the number of unique characters are not even k, for sure I would never be able to make a k subsequence. I have to return the answer as 0, which is the number of k subsequences whose beauty's maximum is actually a 0. That's one such case which we can handle initially. But going on to the main crux, which is the main example, that okay, beauty is maximum. Beauty is maximum. And for sure, the folks are watching, can we please smash, if you have still got the hint, then you just smash the like baby, and can we reach to 40 likes? Just 3 more. That would be super great. Now we want the beauty to be maximum. You saw the beauty is nothing but the sum of the f values. Now if you want some sum to be maximum, then it's highly obvious that you want the individual values to be maximum. So if I want the sum to be maximum, I would want, okay, I will just, and I know that I will choose 2 values, because my k is 2. So I'll just choose 2 values, 2 locations, and I will place the maximum value. When I say maximum value, I mean the f value. F means the frequency. I'll place the maximum frequency value at these locations. Again, for that, I will choose the maximum frequency element. I'll say, okay, if B has a maximum frequency and then the D. So for sure, it is very obvious that I can place in B here and then I can place in a D here. And I'm choosing, why I choose a B? Because it has a maximum frequency, which is 3. It has a maximum frequency as a 2. So I'm very good with it. So what I will do is, okay, I have got a 3, I have got a 2. So for sure, I am done with it. I know that what I can get the B, I can get a D, and I am good to go. Again, can I place anything else? I cannot place a. And for sure, firstly, I have to place only 2 elements. And I choose the maximum frequency element because it will give me the maximum sum. Because they are the maximum frequency. So I'll get the maximum sum. But again, how many such number of K subsequences will be there? You know that, okay, you will have a B and a D with a frequency as a 3 and a 2. But how many such numbers will be there? You know that your subsequence made will be of 2 length. For this D, number of options available for you are 2. For this B, number of options available for you are 3, which means you can place a D. Now, again, how we define a distinct D as it by its index. So this D and this D, both are different. This B, this B, this B, all 3 are different. So for D, I have 2 options. For B, I have 3 options. So number of subsequences I can form is 6. Just a multiplication. Again, because you have to make a both. I have to place both B and D. For D, I have options 2. For B, I have options 3. So for sure, I can place in 6 as my total number of ways. So with this maximum frequency, again, I made it firstly making sure, okay, I should get a maximum frequency. So I just choose in the maximum frequency characters when I have got them. Now, my task is to get the number of K subsequences, which is for that, okay, I just multiply the frequencies so as to get the answer. So that's a simple part which we have gotten. So as to get, again, we went on from back. We went, okay, maximum frequency, which means it should be maximum. For it to be maximum, I need these individual to be as max as possible. So I picked up the as max individuals. Now I know, okay, I can place a B and a D. Now to place a B and a D, to place a B, I have 3 options. To place a D, I have 2 options. Okay, the number of options I can have is 6 total options, which means, okay, I can have 6 such subsequences. Cool. So shall we implement it? Or is there something we are missing out? Let's have a big example, no? So again, we know that we will have our elements. Now, I'm only concerned about the frequency itself, right? So I will just choose whatsoever I want. Let's say I want to make a subsequence of length 4. So I know my K is 4. For that, again, let's have a frequency as 2, B frequency as 2, C frequency as again 2, let's say D frequency as again 2, E frequency as, let's say, 5, and a frequency of F, let's say, as 5. So firstly, you want to place in 4 values, right? You want to place in 4 characters. For sure, you want the sum to be maximum. So you will just pick up the 4 maximum frequency elements. Now, for sure, I will pick up a F. For sure, I will pick up a E. But again, two more elements are remaining. I will pick up a D, B, C, or A. I can pick up 2 elements now, but I have 4 available options. Which one to pick up? Out of 4 options, I have to pick up 2 options. Because for sure, I can only place a 2. I know one thing for sure. I'll place a F. I'll place a F. I'll place a E. I know I'll place a F. I'll place a E. But again, I will have 2 locations left. So I have 4 candidates for these two locations. I have 4 candidates, but I can only place 2. So out of these 4, I need to choose 2 elements to actually place at these 2 locations. So now, okay, I will choose out of 4. I will apply an operation. I will choose the 2 elements to actually place in here. Let's say I choose a and a D. Okay, I choose a and a D. Now, Now, with this choosing, you have made one such combination, okay, A, D, E, and F. But again, as we made a combination, D and B, okay, that's good. But for that, the number of subsequences which can be formed, you have to find, right? So for this also, the 4C2 are the number of combinations which you can form, which has the maximum number of frequency. Sorry, maximum sum or the maximum beauty. But for this also, you know that, okay, how you will form the answer. You know, again, for F you have 5 options, for E you have 5 options, for D you have 2 options, for D you have 2 options, right? Or then simply write the same stuff as again, right, and simply it's a multiplication. So ultimately you want this answer as multiplication, and ultimately when you apply multiplication, you know you have to do the mod and stuff. Sachit Jain bhai, vlog please. Bhai aayega, but the worst part is that you guys don't respond good on vlogs, so I have reduced the vlog frequencies. I don't know, I don't get a much good feedback on vlogs, and it takes quite a lot of time also to get that edit, shoot and all that stuff. So I have paused it a bit. If you guys can have a good response on the vlogs, so maybe more would come in. So yeah, coming back to the problem itself, 2, 2, 5 and 5. Now again, the answer, it will be nothing but it's just a multiplication of it. Either you can just multiply by doing again and again, or you can just, and again, it's a multiplication of 4C2 into this value, because 4C2 you just try to choose out of 4, you just try to choose 2 values. So answer will be 4C2 into 2 into 2 into 5 into 5. Again, for this part, either you can just keep multiplying by yourself and do a modulus simultaneously, or you can also do a 2 square into 5 square, which means here I am just saying binary exponentiation, which means 2 square mod with the value mod, 5 square mod with the value mod. Now it's just a concept. Now the maths part is done. It's just that the implementation, how you solve it. Now this part, NCR, it's nothing but n factorial upon r factorial into n minus r factorial. Again, there are multiple ways to solve it. One way is that, okay, you find the, if you don't know that, it is nothing but, okay, I just get the values of the numerator, I'll get the value of the denominator. When I say numerator, I mean I'll get the value of n factorial mod of the mod value. When I say n factorial, I actually mean n into n minus 1 into n minus 2 up till 1 is some multiplication, which means simply doing a mod. And the same goes for r factorial into n minus r factorial mod. The same kind of r into r minus 1, so on and so forth up to 1, n minus r into n minus r minus 1 up till so on and so forth up till 1, and the entire stuff as mod. So I can get the numerator, I can get the denominator. Let's say it is denom. So if you don't know that, if entire stuff, which means p upon q mod of this mod value is nothing but p into q mod minus 2 mod value, right? That is nothing but how you find the modulus of the upon, like, you know, okay, p into q, I ask you mod, it's nothing but p mod q, sorry, p mod that mod value into q mod that mod value, entire mod value. It is how you solve it. The multiplication mod. For the division mod, it is p into q mod minus 2 of this mod value. But yeah, that should be prime. So this should be prime. Now again, we just have this mod value as 9 plus 7. We can just simply go back and we can simply find our NCR value. Again, that's a concept of NCR, which I've told you right now. That's entirely what you want, or you should know how to implement NCR in the code. You know the simple multiplication, just simply while multiplying, which means a into b mod of the mod value is nothing but a mod m. Let's say it as m. So it is a mod m into b mod m whole mod m, right? Now, when we have done this, we know that NCR is nothing but n factorial upon r factorial into n minus r factorial, which means n choose r, out of n values choose r values. Now again, r factorial, which means n factorial, or basically any factorial is defined as n into n minus 1 into n minus 2 up till 1. That's the multiplication of these n values. And again, if I want to ask you P upon Q mod M, it's nothing but P into Q raised to power M minus 2 mod M. And that's the same for P into Q mod M, which is same but P A into B mod M. So these are operations you need to actually solve this operation. Again, it's a very standard. We have seen this in our videos quite a lot of times earlier also. But if not, then just get this sorted. Again, coming on back, that we just need to solve it down. Again, one of the like other things also, that okay, you also need to know A ratio of X mod M, right? It's just the binary exponentiation which you will perform. Is again, we have just seen it in the many videos previously also, or you can just write binary exponentiation. You can just simply get this solved, that how you find the power modulo, which means for a very large number you can't find a power and then modulo it, which means it is not that you will find the a raised to power x and then you can do the mod. It is not like that. If it is a big power, you have to do a mod simultaneously. And simply a binary means you just break it down, which means you just have ax as actually a raised to power x by 2 into a raised to power x by 2. Like this, you actually solve this, which means it's a repetitive task which you actually can do by multiplying that value itself. So with this optimization, you can just get this value in very less time, which means in the log time. So it's just binary exponential, it's the term. Cool. Now we know that you need to get a 4C2 into that value. Again, that is not, that was a numerical stuff, but ultimately what you will do in the code itself is you will firstly get all the frequencies of all the characters. Now you know that I know that the characters are actually lowercase English letters, so maximum you will have 26 characters. Out of all the 26 characters, you will get the frequencies of all of them in the string S. Right, when you have got the frequencies in the string S, now you can use anything. You can just also sort that down. You can use a priority queue, you can use a multi-set, you can use anything whatsoever. Still, anything whatsoever you use, if you use a priority queue, you will use a size k, because you will push in only the k values in the priority queue, so it will be a kind of n log k, it will be a n log k operation, because you will be going on to every element and then pushing only the elements in the priority queue, only the key elements you will push in the priority queue, right? So that will help you. Or if you can just want, you can simply sort this down also. That's also very okay for us. Again, coming back, if even whatsoever you do, even if you sort this down, but ultimately you want the k maximum frequency elements. So you will just start getting the maximum frequency element. Now I need to know, okay, my maximum frequency is 5. So for this example, we will use a priority queue to actually push in all the frequencies. So in my priority queue, I will have a 5, 5, 2, 2, 2, 2, right? Ultimately, I also know in my mind itself, I want a k as 4. Now, in my priority queue, I have 5, 5, 2, and 2. If I just ask priority queue, hey bro, what is the top value for you? So priority queue will give me a 5. So is it that if I have got a 5, so I can simply place a 5 at this location? No, I cannot. Why? Because I need to know that how much are the 5. What if the 5, 5, what if I had a 5, 5, 5, 5, 5, 5, but I have either 6 5s. So firstly, if I had the 6 5s, I know I can place all the 5s here, but I have 6 5s, right? But I want to choose only 4 5s. So I need to choose also. So firstly, I will just get, okay, if I know, okay, it is a 5, that's good, but firstly bring out all the 5s. Okay, all the 5s I have brought out. Okay, it's just 2 5s for sure. If it is just 2 5s, it means I have more locations. I can just place these 2 5s, both of them I can place. I don't have to choose anything, or I have to place both of them. I'll place both of them. Or I can also say, okay, I have got these 5 is the frequency, right? And its count is actually 2. So I can also say, okay, 5 raised to power 2. Or I can also say 5 into 5. Anything whatsoever works for you. Just have that solved. You can have, okay, because ultimately in your answer you will multiply by 5 square, or basically 5 into 5. Nothing but 5 count. 5's count is 2. So 5 into 5. Again 5 square. Again for 5 square we will use a binary exponentiation mod m. right? Cool. Going on back, now my k left is actually a 2. My k left is actually a 2. Again, मैथ वाला स्टफ दिमाग के बाहर गया ब्रो, प्लीज सिंपल वे में एक्सप्लेन कर दो. सी दैट्स Vamsi, don't spam leads to ejection of. Okay, yeah, bro. See, Krishna, that's the basic maths for programming, and I just highly recommend that you should be knowing this basic maths, because see, I will not rate this question as hard. We have seen much harder questions of maths on this channels, and that's not very late. Like last in a month, we have seen much harder questions of maths. That's a much easier variant. Just knowing NCR, just knowing simple factorial, and just knowing a simple binary exponentiation, you will be able to solve it. And these three are the very basic of maths operations. So that's very, and see, that it should be very normal for you up till now. If not, then just try to watch it. Just have that in your notes. At least write that down. Maybe in future, if you will encounter more problems, you'll just get this sorted. Cool. Now we can have this value. Just have, okay, answer is equals to 1. Keep on multiplying with your answer these values which you are getting. Again, now your k left is 2. For k left as 2, you will get the next higher value. Now the next higher value is a 2. Okay, but you know that, okay, you will get all the 2s. Okay, I'll get all the 2s. So 2 is actually the frequency. Ultimately, it just says the frequency, and count, which means, now when I say frequency, I actually mean the frequency of characters, right? The count of these 2s are actually 4. I'll put in a 2 here, but I know, okay, the count is actually 4. Okay, I place a 2, but I can choose only 2 such 2s out of these 4. Out of these 4, I'll choose 2s. So 4C2, which means out of the count, I can choose only 2 because I have remaining places as 2 only. And with that, okay, I'll just say, okay, multiply my answer with 4C2 also. And also now I can just place 2 of the 2s. 2 I can place. So nothing but 2 is equal to mod m. Again, just do a mod m at every operation, and you will simply get this solved. You can simply keep on repeating the same process again and again until you have got all your k's, or you have exhausted all your k's. And that's how you can simply get this solved. Again, for this, I took the example itself as specifically as A, B, C, D, E, and F, and not by this 2 and 2 and 2, because with this 2 to 2, you will get confused. So if you have not got the last part, so please watch this previous part of how I'm using the examples itself to actually get the values, and why these values, why this 4C2, which means out of all the A, B, C, and D, I can only choose 2, which means A, B, C, and D are the 4 options. I can choose only 2 options. So I can just choose 2 options. That's as 4C2 for that. Now, when I have chosen 2 options, okay, let's say A and D. Let's say A and D, which means out of these 4C2 options, I have chosen one option, A and D. For that, the impact in my answer will be 2 and 2, because A can come in 2 times, D can come in 2 times, because when I say 2 times, I mean A was at 2 different locations, or in my entire string S, the frequency of A was 2. So I can pick an A at 2 locations, different locations. So available options for A are 2, available options of D are 2, available options of E are 5, or available options of F are 5. And that's how you can simply get this solved. And now we'll just simply, just code this down. Again, the entire logic at this particular screen right here only. Again, if you have never ever watched a binary exponentiation, I highly recommend just go and watch it. Although I'll explain in the code also, but still, binary exponentiation, or if you have never even heard of NCR, again, although I have shown you what this NCR means, just N choose R. But still, if you have not heard, just go and simply do a Google search. What's the NCR? How you choose R values out of N values? All that stuff. Just a basic, very basic maths required for programming as such. But yeah, that's a simple solution. We'll quickly jump onto the code. Again, if you have any questions down below, just write that down. Before that, can we please smash that like baby to 55 likes? Just three more, that would be super, super, super great. Now, going on to the binary exponentiation part, as I showed you, again, it's nothing but you cannot compute power mod n in the actual internal library, so you just have to write your own function to compute the power. Again, it is with mod values. You can't do although you can get a power function in your internal library also, but not via some mod. So for that, you have to implement the answer. Nothing but what we do is we just assume to get the for the power of like by 2, because you know that okay, you will just multiply that value again and again. You saw that I did a by 2 and just multiplied the same value again and again, so as to just reduce the number of operations, so that the log to the base 2 operations comes in picture. Right now, again, if it is actually a odd value, which means okay, I can't divide that by 2, so simply multiply that x with that value in your answer and simply get this solved. Again, I will not go into details of binary exponentiation part. If you want, if you have not known, because it's a standard which we have taught and learned previously quite a lot, but if you don't know binary exponentiation, just write on Google binary exponentiation by Aryan Mittal. You will get a video. Just watch it down and simply get this solved. Or you can just simply pick this up as a black box and assume it will give me the power of x raised to the power n mod of this mod value. You can just assume that it will give you this value, right? Correctly. Now, this is part of factorial. Again, I will not say this is the best way to actually implement it, because it is much more convenient to store the value in an array, which means okay, if you have stored the factorial value in the array, then what it means is that if you have the value of 4 factorial, then factorial of 5 is actually nothing but 5 into factorial of 4. So it's much more, rather than computing that same stuff again and again, it's much more convenient that you just store the values in some variable or in some array, let's say name it as factorial, and then use it down. Again, although that the constraints are not that big, so you can just compute that again and again, which means for factorial 5, here right now we're computing as 5 into 4 into 3 into 2 into 1, and for sure mod is every time applicable, which means at every multiplication the mod is being applied. Make sure that part. So right now we are doing here, but again I'm saying it's not the best way to implement it. Best way to actually is use the array itself. Now again, we have got the factorial. We also want the NCR value. Again, as I showed you, NCR is nothing but n factorial upon r factorial into n minus r factorial, which is, let's say this is as the denominator, like numerator, this is as a denominator, and for p upon q mod of that mod value, we get a p into q raised to the power mod minus 2 entire mod, right? So that's the same stuff which we have done. Firstly, we get the denominator value, as I showed you, factorial r into n minus r factorial whole mod. Now we want that okay, whatsoever our numerator is into the mod minus 2 power of that denominator multiplied, so as to get it up and get the actual answer. And for sure the mod is done every time, so as to get the NCR. Again, I am saying don't put much brain if you don't want to apply much effort on it. Just assume as black box to get the NCR, black box to get the factorial. But I'll say memorize this factorial part. It will help you a lot in the better problems, because here the complexity is not that good, so not that big, so it would work again and again, but I'll not recommend this. Cool. Now we actually go on to the main part of the code. We saw that okay, we want to get the frequency of every character. So for every character I'm getting the frequencies increased by +1. Now, as I am saying, okay, I've got the frequencies of every character. I'll push on those frequencies also only in my particular priority queue. As you saw above also, sorry, below also, I pushed in only the frequencies. As you saw here, 5, 5, 2, 2, 2, 2. Like, we only push the frequencies in our priority queue. So got it. We have pushed in the frequencies in our priority queue. Now, okay, I've got the frequencies only in my priority queue. which is for the frequency of all the distinct elements, right? It is the priority queue will have the frequencies only. And again, I'm saying that is kind of just showing that, okay, if you have the frequencies as 5 5 2 2 2 2, which means you have 5 1 2 3 4 5 6, you have 6 distinct elements. As you can see also here, I had A B C D F E and F. If the elements would have been same, which means if it would have been E only, so it would have added the frequency as 10 and it would have not been a 5 5, right? So that's how we are actually saying the priority queue size is actually showing us number of unique or the number of distinct values. Cool. So I just checked here itself if the size is less than k, which means I don't have k distinct values. So for sure I can never make in my entire life a subsequence of size k, because a subsequence can only be made if it has all distinct values. Now when this is done, as I showed you, I want the multiplication to be going on forward. So I initialize my answer with 1 because I'll keep on multiplying that value. Now again, until I have exhausted my k, I'll firstly get the count. So like it's just an initialization. I'll get the topmost frequency element, as I showed you. In this, I'll get the topmost frequency element, which is 5. Okay, I've got the 5, but again I have to get all the 5s. Okay, I'll get all the 5s, which means I have to get the count also. So I've got the topmost frequency element, which is I'll keep on iterating in my priority queue, and I'll just say, okay, just count the frequency, count equal frequency element and keep on increasing. Now I have got all the frequency element, which means the top frequency element. Now when this is done, I know the frequency, I know the count of that equal frequency also. Again, that's a frequency is 5, the count for that is 2. Now for me the k is actually initially 4, so my 2 is less than or equal to 4, which means I have just, as I showed you here itself, I can just place in 5. I don't have to choose between those 5s. I have to place both the 5s. That's a restriction for me. So I'll just place both the 5s right here at this location. Both the 5s. I'll place it. So it's a compulsion. So I'll just place in both the 5s. Now for that placing, I know, okay, I placed 2 5s. Both the 5s, which means the 5 frequency was 2, the count was 2. So I just used both the 5s. So now my k has reduced to 2. Now I'm just thinking, okay, now the next time I will think of k as 2 only. Great. But I will increase my or multiply my answer with 5 square. So I just did the same stuff. It is nothing but 5. It is nothing but 2. Multiplied my answer. Answer is initialized to 1. So my answer is nothing but multiplied by 5 square. Cool. And then mod is nothing but done always. Cool. Now again, I will just pick up the next frequency element, next frequency, which has the topmost frequency actually 2, right? So now getting the frequency, getting the count of that particular 2 is actually a 4. But now you remember that my k has reduced to 2, which means I have only two positions left. So which means it will not go in this loop, it will just go into else. Now, firstly, out of 4 locations, I have to choose 2. 4, I have to choose 2. So I'll just choose 2 out of 4. Okay, now I have chosen 2. Now just place these frequency element 2 and 2. So nothing but I know that, okay, I'll get a 2 and whatsoever k value as I had remaining, I'll just get that and just sort this out. So firstly, I just multiplied my 2 power k, which means the frequency element which was 2, and the remaining k was actually also a 2. Right? I just multiplied that with my answer, and I also multiplied a 4c2, which means nothing but count of equal elements, which is 4, and the remaining k which I had, because I had remaining only 2 positions, that's a 4c2. And you can just keep on repeating this until you get it, because ultimately you just did this at the end. So you can just simply break this down here itself, or else you can just remove all this. You can just reduce your k to 0 ultimately in the next time, also like ultimately in the next time it will itself break out of the loop itself by itself. So no worries on that part, and simply return the answer. I hope that you guys got it. That was a kind of a, like, see, if you had known NCR inverse, modulo multiplication and binary exponentiation, then it should be a pretty easy question for you. If not, highly recommend. Please go and learn that. It is very important. Again, in my internship first in my internship interview, and I'm saying the first question asked was completely maths based and completely PNC based. The entire question went on for 1.5 hours. That was not even a close. Like it is a very easy question for PNC. That was a very kind of a medium to hard question of PNC, and that too involved everything like inverse, modulo, bias pronunciation, like standard, like not even like simple permutation but also combination part, which means simply arranging stuff also. Right now I just choose the stuff. There's also NPR, which means you can also permute stuff. So again, that's important, very important. That's the reason I'm just specifically focusing on this part. Cool. We quickly have a chat read. We'll end the stream in about a minute or so. So if you have anything to write, you can just write that down. But before that, can you please smash that like baby to 55 likes? That would be super, super, super great. Just one more, that would be super, super, super great. Appreciate the stream and daily videos. Thank you, Sid. Don't feel it is a fad from this frustrated engineer. Sorry if it hurts you. From where to prepare for aptitude for Goldman Sachs engineering? Like, that's not like Vamsi. It is. Look, see, it's always like a bit luck factor will also come in every time it comes in. So it's never that you can blame yourself. Okay, if you're not getting selected, it's not on you always. There's always a luck factor also, and that plays a very important role. That what interview you are getting, how he or she has a mood at that moment. Also, like although the mood is not that much dependent, but still, like what interview you are getting. If the interview is, let's say, a very high professional or like very kind of a person who has a lot of experience, so he will ask very easy question. But if the one like easy answer, like easy DSA question, but if the one is who's new, like let's say me or someone else, so maybe we'll ask probably a bit tougher question. So that can be like how the interview are getting. But yeah, still people are judged on multiple bases. So again, a luck factor will come in a lot. So I'll highly recommend, see, for Chandrika, I like highly recommend just like for aptitude and stuff, just go and search on like GFG and stuff. What's the questions asked? But what I say is mostly they ask mathematical aptitude questions involving rain, boat problems, and I mean like actual PNC problems also in aptitude. So maths is very kind of important, a bit on English side and all that stuff. So from where to prepare, I have made the entire video on it. If you just write online assessment by Aryan Mittal on YouTube, you'll get the entire video of more than 20 minutes. That video has everything whatsoever you want for aptitude, but I'll highly recommend for Goldman Sachs specifically focus on maths part of aptitude rather than reasoning part, because reasoning part is not asked that much. Maths is kind of primarily focused on quite a lot while in interviews itself, so I recommend. So please at least have your NCR, NPR, these kind of stuff sorted, because there can be a chance of people asking. Cool. I hope that but yeah, I just completed an SG internship at remote startup, so my experience section is updated, but I got a very bad GPA this sem. Now I just entered the third year, so should I start CP or just do DSA? Firstly, like you should start CP for sure. Like only DSA, see, only DSA if you're doing it a lot, I mean as in like Leetcode contest a lot, so that would be very good. But I highly recommend, like if you have time, so please start CP also. Let's say like you will encounter CP problems in DSA problems in CP, so that's a mix. But yeah, you can do it. But please don't get demotivated by CP ranks. CP is much more of a fast-paced contest, bit more mathematical, bit more ad hoc. So people are a bit more irregular, rating decreases. So please don't judge yourself by the CP rating which you get. if you don't get mentally affected by that, so please do CP. I highly recommend that. Else it's good. Focus on GPU also. That is beneficial also. I watched your video that was 2 years ago. Your transformation is OP. Thank you so much, Pranav. Hi, Bhaiya, I'm Stacy. I will start DP from tomorrow. Please give me some advice before that. It will be super helpful. I mean, like for DP, you can just start off with, see, although you can just go watch people's DP plays and stuff, but I'll highly recommend, if you know simple recursion, if you want, you can start off with the basic DP. You can just start off with the 1D DP and stuff, but I highly recommend studying anything whatsoever apart from graphs is just a BS. Just start off with any intuition building playlist, which means, let's say if you want to study DP, just you can start off with a DP intuition building playlist and just keep on going forward, which means you will get the problems, you will get the intuition on how to build, because you know, okay, it's a problem of DP, but still, how to build the recursion, how to build, it's a DP problem, it's a big task. So, and there are 50 problems in that particular place or more than that. So, highly recommend just go with that. Or if you want, you can also start with some playlist itself. Many people have already made the playlist. We have also a playlist of DP, but it's just a 1D DP kind of playlist. But still, you can just have it done anywhere from whatsoever you can. We'll end the stream soon. Can you please smash that like baby to 60 likes? Just 2 more, that would be super great. Cool. The guys on the Aryan bro, just stop kidding. Yeah, is there any 0.0001% chance of getting companies like Goldman Sachs? We, the guys from tier 3 college, our life is full of failure. No, yeah, that's see. From in our company also, there are many folks from tier 3 college. So that's not, see, again, I'm saying it's highly dependent upon the round, how it went and who took it, and also like what they liked about you, because there are multiple factors you are judged on. Multiple, again, I'm saying it's not even entirely coding, it's multiple, but yeah, still, if we can just improve the coding part only, that's a primarily major factor. Like your 60% is based on coding, remaining 40 is your how you speak, confidence, projects, knowledge on different aspects of your stuff which you have written in resume, all that stuff. But like primarily programming is the most important. So I'll highly recommend, yeah, don't get demotivated for sure. See, it's easy to crack. It's for sure easy to crack. You will be sitting one day beside me working. Just put in thoda sa or hard work. If it's still hard, then I'll also like say, okay, you can have it. And also, if not, then you can just try off. See, it's always, see, there's always a point you would know that, okay, that's way too much enough and I have been stagnant at this location in CP or in DSA. But DSA, it's never stagnant. That is, like, as such, you can always more or less even like reach to question number 4th anyway whatsoever. But in CP, it's just always a race, kind of, okay, master, candidate master, all that stuff. But coming on back, you can just, I'll just say, like, have थोड़ी बहुत more hopes. पक्का हो जाएगा वामसी, पक्का. Why DP is not working in this question? Can you explain? See, firstly, for DP, let's take the simple basic stuff. You would need a recursion. For recursion, you would need to actually hop onto the like all the indexes. Now, for that, you need to maintain that the subsequence formed for you is actually of size k. Sorry, the subsequence formed is actually k. Now, again, for that, if you land onto an index, you will maintain, okay, how many number of elements I have got so far. Now, if you have got the number of elements so far, now you will just keep on getting the new elements, which means you can just get the new map again and again. One way DP can work, but that will give you TLE is you just maintain, okay, as you're building. Now, I have just put in, let's say, a A here. Cool. I can put in a B here. Cool. But firstly, you have to make sure that you are only putting and using the maximum frequency element. Again, for that part, let's say if you have chosen D, as I showed you, the best example, you have taken this itself, the one I showed you at the bottom, the frequency you have chosen as this. Let's say you still had A, B, C, D, E, and F. Again, for this, you know that you need firstly you need to know that you will only choose the maximum frequency element. But on top of it, you will also need to choose that, okay, whatsoever remaining element is there. Now, which means first thing which you have to fix, if you want to choose a DP, you have to fix one thing. What's that one thing? That one thing is what element in what order you are going to choose, because you will only choose some specific elements. Now, after choosing those specific elements, you can just start building recursion, and that would be as equal to your DP itself. But the entire part for you is already done, which means you will choose the order of the elements, which means you need to choose, okay, you will choose the fives first, which means you will choose the E's and the F first. Okay, I need to choose E's and the F first, and then I also need to apply a 4C2 and then choose two elements, let's say A and B, right? So ultimately, you now know that you can only apply operation on these four characters. Again, you can apply recursion, you can apply memorization, but you have to fix. You will apply on these four characters itself, and also a maths part will again come in. You can't just say, okay, I'll apply and choose maybe A, maybe B, maybe C. No, by this you will end up choosing all of them, or maybe A, B, C, D, and you might not even choose E and F. You want, okay, you will choose F, E, and then either A or B, because for sure you have already chosen, okay, 4C2. So basically you will choose A and B, and then, okay, I'll choose A and B. Now, in your recursion itself, you will be choosing A, B, E, and F only, and with that you can build the recursion. What's the point now? Okay, now if you know, okay, you can choose A, B, E, and F. So you have fixed. Now you will choose only these four into 4C2 will be your answer. So now what's the point of recursion writing? You can, but still, you can write the recursion. If you have a E, you can just use that E. If you have a F, use that F. If you have a, use that A. If you have a B, use that B. But still, it will take K space more and also time more. So that's the reason. Like, if you had done the entire stuff, that's much better. That simply multiply with the frequency of that particular element. Why to even choose that element? Because you will have to choose that element on the frequency, because your main task was what? Getting the frequency sorted. You should have the maximum frequency. But if you say, okay, Aryan, I will not go in that frequency, I will compute the frequency on runtime, and then the one having the maximum frequency. So basically what you will end up doing is you will end up maintaining a map of this sum to the count of number of frequencies of that, some map of this value to the count of frequency of that, map of this to the count of frequency of that, and then maybe in the end, okay, when you have this entire map, okay, what is the sum, which means the beauty, to the number of k subsequences for that particular beauty, and getting the number of k subsequences for that particular beauty. One way is this, but for that also, what you will end up doing is you need to know for that beauty as, let's say, 3 or 4, for that beauty of 5, let's say again 5, let's take the back the same example. I need a beauty of, let's say, X, which I will get as the maximum beauty whatsoever. I need to start choosing some elements. When I will start choosing some elements, I need to bind myself to choose some specific values. either I can just start choosing everything, which means I'll choose a A, then I'll choose a D, then I'll choose a E, then maybe I'll choose a C. But then the sum which will come in, it will come in as, let's say, x2, but I want the sum as x1. Again, I can choose A, then C, then D, then F. Again, I can get sum as X. So when I have got this sum as X, that will keep on repeating for every what? For every index. So for every index, now the complexity part will actually start increasing. For every index, you know for sure in a recursive code, index will come. So which means you will choose a B, B, D, E, E, D, C, F, F, C, and so on and so forth, right? So you will just start choosing, okay, I'll choose a, I'll choose a B, I'll choose a E. Now, you know, you can choose only 4. So you will end up choosing, with that, you will also maintain a map of 26 characters, because you need to iterate on all the characters to actually know, okay, which new index you can choose, because you can choose only 4 distinct values. Now, when you will end up choosing it, you will also end up computing its actual sum. Again, a factor of 26. Again, n factor will always come for sure. So that is the reason. N into 26 into 26, or again, that's the basic composition which will come and see. You can actually solve it, but again, for that, the complexity will increase, as we can see here. So I highly recommend, again, going back, if you can actually solve it with DP also, but again, for characters going on, you are just going on to the same character again and again, which means here I went on to a, let's say, F, right? Again, F will come on thrice again as well. So it is one such combination, 1, 2, 3, 4. Now 5 can be this, 5 can be this, 5 can be this also. So again, for that, you will have more of these 3 combinations. So again, that will have a factor of 26 coming in the picture, which will actually increase the complexity, which can actually turn in bad for DP. So as in DP to solve in, you would be able to solve it with some optimization stuff. But again, I think it's kind of a going back, like coming in the math problem and then going back to again the DP. Is that okay? DP as in purposefully we are actually placing in to actually solve this problem and not it's required. So I hope that solves. Who was that? Royal Chaudhary. We will end up the stream in 2 minutes. फोर्थ भी हो गया और कॉन्टेस्ट के बाद, फोर्थ भी हो गया और कॉन्टेस्ट के बाद. That's great. How to pick up quality problems for practice other than the sheet and contest. If you want to practice specifically some specific topic, just to sort it down, or else just sort it on the basis of frequency on the main Leetcode page. If you cannot, just download the Leetcode premium plugin. You will be able to solve it, and that would be it. Cool. Yeah, that's pretty much it. Thank you so much for watching. Before going, can we please smash that like baby to that would be super great. Cheating at its peak. Yeah, that happens. That you can't blame out. That will happen, and that will keep on happening. So there's nothing which we can do in this. But yeah, cool. Thank you for watching. See you guys. Bye. Goodbye. Thank you. Take care. We will see you in the next stream tomorrow. Bye. Cool. Bye. My voice is gone. Legit, it's gone. Bye.